In this video, we are going to solve May 2024 Pure Math 1 paper. This paper consists of 11 questions. Question number 1 is from integration. Just a simple 3-mark question. You just need to integrate it. Before you integrate this, write it this way: integral 10 to the power x power 10 x power 4 minus 3 over 2 x power minus 3 minus 7 dx. So when you integrate, it becomes 10 x power 5 over 5 minus 3 over 2 x power minus 3 plus 1, which is minus 2 by minus 2. 7 becomes 7x plus c. Simplify this. 10 over 5 is 2x power 5. When you simplify this to, it becomes positive 3 over 4 x power minus 2 minus 7x plus c. That's all. That's the answer. If you want, you can write this as this particular term as 3 over 4 x power positive 2. Even you don't write that way, you'll still get the answer. This is correct already. You can stop right here. You don't need to change it to a positive power. Question number 2. Given that m is equal to 2 power n, express each of the following in terms of m. You have a, you have 2 power n plus 3. Apply laws of indices and split it. You can write it as 2 power n times 2 power 3. Replace 2 power n by m. 2 power n by m, and the value of 2 power 3 is 8. So we'll get 8m. That's all. Just a 1-mark question. Now part B, you have 16 power 3n. The base is 16 here, but we should have 2. So I'm going to change 16 to, I'm going to write 16 as 2 power 4 is 16 power 3n. The laws of indices says when you have a power m to the power n, you can multiply the powers, right? So when you multiply 4 times 3n, you'll get 12n. You can write it as 2 power n to the power 12 and replace 2 power n by m. So it's m to the power 12. Question 2, double A. Solve the equation and give your answer in this form. So whenever the question says solve the equation, you need to find the value of the unknown x here, right? So you need to collect all the terms involving x to one side. X root 3 minus x is equal to, put this minus 3 this side, root 3 plus 3. Take x as a common factor, you will get root 3 minus 1 is equal to root 3 plus 3. So x is going to be root 3 plus 3 divided by root 3 minus 1. And then rationalize the denominator. Multiply and divide by root 3 plus 1. So on top it's going to be, take root 3 and multiply both, you'll get 3 plus root 3. Take 3 and multiply both, you'll get 3 root 3 plus 3 divided by. You can do the same thing for the denominator, or you can apply the algebraic identity. A plus b times a minus b is going to be a square, root 3 square is 3 minus b square. So on top you have, when you simplify the like term, 6 plus 4 root 3 divided by 3 minus 1, 2. Divide each term separately by 2. You will get 3 plus 2 root 3. 3 plus 2 root 3 looks like this, right? That's the final answer. Question number 3 now. We have a figure given, looks like a cubic graph. It says figure 1 shows the sketch of the curve with the equation y is equal to f of x. The curve passes through minus 1, 0, 0, 2, 3, 0. Minus 1, 0, 0, 2, 3, 0. 3 points. Sketch the, on separate diagram, sketch the curve with the equation y is equal to f of x plus 3. Okay, I'm going to put it here separately. There are 3 points on the f of x given graph. Minus 1, 0. 0, 2 and then 3, 0. Now when you apply this transformation f of x plus, part A says f of x plus 3. You should have learned this in chapter 4, graphs and transformation. If you replace in a function f of x, If you replace x by x plus 3, it's a translation to the left side 3 units. So we are going to move the graph to the left side 3 units. So you need to subtract 3 from the x coordinates. So when you subtract 3, minus 1 minus 3 is minus 4, 0, that's a transform point. 0 minus 3 is minus 3, 0. 3 minus 3 is 0, 0. Y coordinates will not be affected. So you plot these points. Let's say minus 4 is in here, and then minus 3 is in here, and then 0, 0 is in here. Wait, 0, 2 becomes not minus 3, 0. Y coordinate will stay the same. So this graph is going to be translated. Maybe I'll sketch the graph on top of this just to show you how the new graph will look like. Let's say minus 3 is here, minus 4 is here, minus 3 comma 2 is in here, minus 3 comma 2 is in here, and then this point becomes 0, 0. So you're going to get this graph. 0 becomes minus 3, right? You'll get this graph. So the graph has been moved to the left side 3 units. So this point is minus 3 comma 2. And then they want you to mention the points in the coordinate form. So put it as, instead of minus 4, just put it as minus 4 comma 0. Here origin, you mention it as 0 comma 0. You have to draw it separately. Don't draw it on the original graph. I have drawn it on top of the original graph just to show you the difference between these two. Now the second transformation, f of minus 3x. What I would usually do, instead of treat this as a single transformation, that's allowed also. You can just treat minus 3 as a single transformation, or just sketch f of 3x. That's a stretching along the vertical axis, along the horizontal axis, and then f of minus 3x, which is a reflection over y-axis. So that's what I'm going to do. First, when you sketch f of 3x, all the y coordinates, all the x coordinates will be divided by 3. So this becomes minus 1 over 3, 0. Let's say minus 1 over 3 is somewhere here. 0 comma 2 stays the same. This point 3 comma 0 becomes 1 comma 0. Let's say 1 is in here, and the y coordinate 0 comma 2 will not be affected. So the graph will be like this. This is 1, 0. This point is basically minus 1 over 3 comma 0. That's f of 3x. Now to sketch f of minus 3x, you have to flip the graph this way over y-axis. So when you flip it, you're going to get piece here. Instead of positive 1, it's gonna go through negative 1. This is the graph. And definitely you need to mention the points. This is minus 1 comma 0. This point is 1 over 3 comma 0. Y coordinate is 0, the same point, 0 comma 2. That's the graph f of minus 3x. Question number 4 now. You have curve C1 with equation this, and C2 with equation this. Given that C1 and C2 meet at a single point P. So whenever the question talks about two curves meeting a point of intersection, you have to equate them. So you can write it as x square plus kx minus 9 is equal to minus 3x square minus 5x plus k. And then put everything one side, move everything one side, you will get 4x square plus 5 plus k times x, take x as a common factor, plus minus 9 minus k. That's the term independent of x. Why I'm writing this way? Okay, these two curves meet at a single point. In other words, this function will have only one solution, this quadratic equation. If the quadratic equation has one solution, the discriminant will be equal to 0. So b is the coefficient of x, for a is the coefficient of x square, c is the constant term, is equal to 0. Open the bracket, expand it, you will get this answer. So it's going to be 25 plus 10k plus k square minus 4 times minus 4 is minus 16, negative 16 times negative 9, you'll get 144 plus 144 plus 16k. Simplify the like terms, you will get 26k, and then add these two, you will get this also. That's all. Part B says, hence find the coordinates of the point P. So you need to find the values of k first by solving this equation. So I'm going to use my calculator to solve it. Go to quadratic, k square is 1, k is 26, constant term is this, you'll get minus 13, you'll get only one value. So how do you write it? K square plus 26k plus 169 is equal to 0 can be written as k plus 13, k plus 13 is 0, k is equal to 13, k is equal to minus 13. So using this value of k, you need to solve the quadratic, you need to solve this quadratic equation by subbing the value of k here, minus 13. So this becomes 5 minus 13 minus 9 minus 13. So the question got 3 marks actually. Okay, so it's going to be 4x square and then 5 minus 13 13x plus minus 9 minus k is equal to 0. So you'll get 4x square minus 8x plus 4 is 0. Divide through by 4, x square minus 2x plus 1 is 0. You can write it as x minus 1 times x minus 1 is 0. There is only one point, x coordinate is 1. To find the y coordinate, sub in the value of x into any one of this equation. I'm going to use the first one. Y is equal to x square plus kx, k is minus 13 times x minus 9. So you get minus 22 plus 1 minus 21. So the point of intersection is 1 comma minus 21. That's all.